Good afternoon, ladies and gentlemen. Today, we're going to be writing equations from tables, meaning you're going to be given a table and you'll be able to write an equation that represents that table. Let's see how we're going to do that. So by the end of the day, you'll be able to write equations from proportional relationships, and you'll accomplish this by finding the constant of proportionality from the table. Now, hopefully you already know how to find that constant proportionality, so it's just a matter of applying that in order to write an equation. Now, if a table or graph illustrates a proportional relationship, then you can write an equation, okay? All proportional relationships have an equation that represents that relationship. And equations can help us with lots of things like finding unknown values. So here's the general format of our equation. Okay, it is y equals k, which we know is our constant of proportionality, times x. Now y is our dependent variable, and x is our independent variable. Now we're not going to get too deep into this, but the independent variable, think about it. Independent means that you do what you want. You're on your own, right? You can do whatever you want. Independent variables, the value of that generally happens first. Okay, we put in the x value and we get an output of the dependent variable. The dependent variable, the y variable, depends upon what the x variable is. Okay, now don't worry too much about that. You'll probably get more of it next year in 8th grade, but just right there, it's in the wording, independent. It does what it wants. The x value can do what it wants. It comes first in the alphabet, right? X comes before y. X does what it wants. And then the y value, well, the value of the y depends upon what x is. It's dependent upon x. And k here, again, is our constant of proportionality. Now, let's go ahead and look at some equations here. Let's look at this first one down here, and we're just going to figure out what is our constant of proportionality. Remember, it's in this form, y equals k times x, where k is our constant of proportionality. Well, I can just write this right above here, y equals k times x, and we see that our constant of proportionality is 3, right? We've just replaced the k with 3. So k is 3. Our constant of proportionality is 3. For this one, y equals k times x. I can write it right above, and I can see that my constant proportionality, my k value, is 1/2. Let's have you go ahead and find the constant of proportionality for both of these. We'll call this number 1. So you can answer both of these in the same question there. And 2. All right, for number 1, I didn't mean to clear that. For number 1, our constant of proportionality is 1/5. And for number 2, our constant of proportionality is 6. All right, so do these equations show a proportional relationship? Do they match this format here? Are they in the form of y equals some number times x? Well, let's take a look. This one, y equals k times x. Sure enough, look at, we've just replaced the k with this 4. So this one is a proportional relationship. This next one over here is not in the form of y equals k times x. It's in the form of y plus some number equals x, right? There's nothing being multiplied there times the x. Well, there is a 1 if you want to be technical there. But again, it's not in this format. It's not in the format of y equals some value times x. So no, this one is not a proportional relationship. Go ahead and see if you can determine if either of these are proportional relationships. All right, if you said this first one is a proportional relationship? You are incorrect. There's no x here. So just y equals 4, right? It needs to be in the form of y equals 4 times x. If there was an x there, now that is a proportional relationship. But as it is, this one is not a proportional relationship. How about this one here? Yes, it is, though it is backwards, right? We can rewrite this as y equals 8 times x, and now it is in the form of y equals our constant of proportionality times x. So this one, yes, is proportional. There we go. All right, so how do we write an equation from a table? Well, first we need to determine if the table is proportional. If it is proportional, then we need to find the constant of proportionality, which remember is the same thing as our unit rate. It is y over x. You can take any value and make y over x, any data point I should say, make it y over x, and that will be your constant of proportionality. Then you're just going to replace k in this equation, and that will be your equation. Let's go ahead and try one of these. So first of all, does the table show a proportional relationship? Let's find out. Remember, in order for this table to show a proportional relationship, all of our y over x's need to be equivalent, need to be equal. So let's just do this one at a time here. Let's start with this one here. Okay. Remember, it's y first and then x. So that's 8 over 4. Okay, that reduces down to 2. Check our next one here. 14 over 7. That reduces down to 2. Looking good so far. Take a look here. 16 over 8. That reduces down to 2. And finally, 18 over 9. And that reduces down to 2. So what is the constant of proportionality? So first of all, yes, we have a proportional relationship because all of our unit rates are the same. And if we have a constant of proportionality, then there exists a constant of proportionality. If we have a proportional relationship, then there exists a constant of proportionality. And that constant of proportionality is our unit rate. It's the same thing here. So K is equal to 2. So what is our equation? Well, we're just going to take this K, we're going to remove it, and we're going to put 2 in its place. So Y equals 2 times X. And that is our equation. Now let's look at this. This equation helps create this table. If we put in this value of x in here, 4 times 2, it will give us our y value, right? So 4 times 2 is 8. Let's try 7. 7 times 2 is 14. 8 times 2 is 16. 9 times 2 is 18. So you can see how if we put in any of these coordinate pairs here, if we put them in for x and y, it will work out to be a true equation. All right. Let's go ahead and take a look at another example here. Let me sneak back really quick. Let me see. Okay. All right. During the summer, Kiara works on her uncle's dairy farm. One of Kiara's main chores is to load bales of hay onto a wagon and haul them from the wagon into the barn. They're telling you here there is a proportional relationship. There's no question about it. They're telling you right there, there is a proportional relationship. So we're not having to determine if there is one. We know there is one. So that means that all of these unit rates are going to be the same, which means that the unit rate for any of these data points will give us our constant of proportionality. You can do any of these. Let's take a look at 34 over 2. Remember, it's always y over x. Okay, 34 divided by 2 is 17, right? That'd be the same of any of these. 17 divided by 1 is 17. 68 divided by 4 is 17. 85 divided by 5 is 17. So what is our equation? Our equation is y equals 17 times x. Now think about it. That makes sense, right? This equation is saying take this value, multiply it by 17, and we will get this value. Take this value, multiply it by 17, and we get this value, right? That's what this equation is telling us to do. Take our x value, whatever it may be, multiply it by 17, and we get our y value. Go ahead now, try this one. What is our equation for this table? Again, they're telling you it is proportional. All right, we can take, again, since we know this is a proportional relationship, we can take any of these points. I'll take this first one, I'm looking at y over x, so that is 40 over 2. 40 divided by 2 is 20. So that is my constant of proportionality. It is 20. So what is my equation going to be? Well, that constant proportionality is just telling me what I'm multiplying x by to get y, right? So what does y equal? It equals 20 times x. And here's the IXL skill you'll be practicing and mastering in no time at all. K2, go ahead and get working on that. And hopefully I'll see you back here on Monday. Bye, guys.